Okay, in this video we're going to talk about hydrohalogenation of alkynes. And I think you're going to find this is very similar to the hydrohalogenation of alkenes. So if we add a HX, where X is a bromine or a chlorine or an iodine, we can get Markovnikov addition to an alkyne just like we do to an alkene, right? In this case, the hydrogen adds to the less substituted carbon, the halogen adds to the more substituted carbon, and we get Markovnikov addition. In very much the same way, if we add HX to an alkyne, the halogen adds to the more substituted carbon, and the hydrogen added to the less substituted carbon. If we react our alkyne with excess HX, then we can cause the reaction to drive all the way to the dihalide, where both halogens add to the same carbon atom. So if the mechanism for the hydrohalogenation of alkynes was the same as the mechanism for the hydrohalogenation of alkenes, then it would start with a proton transfer, but that would give us a vinylic carbocation. We've got a positive charge on a carbon that's participating in a carbon-carbon double bond. It turns out these vinylic carbocations are extremely unstable, and so this is likely not the mechanism that the reaction follows. There's also kinetic data to suggest that this is not the correct mechanism, and it's highly likely that there are probably several competing mechanisms occurring. And so we're not going to go through the specific mechanism for the hydrohalogenation of alkynes. What I do want to talk about is when we react HBr in the presence of peroxides, we get anti-Markovnikov addition just like we did with the alkenes. And in Chapter 10, we'll talk about why this only works for HBr and not with HCl or HI. All right, so if we look at a couple examples, so we want to predict the products of each of these reactions. So I'm reacting my alkyne with excess HCl. So this is going to drive us all the way to the dihalide, and we're going to get Markovnikov addition. So my products, right now I have to be a little bit careful, right, when we count the carbons with the alkynes, right? I have 1, 2, 3, 4, 5, 6 carbons in my chain. 2, 3, 4, 5, 6. The methyl group's on carbon 1, 2, 3, 4. So 1, 2, 3. Here's my methyl group. And then both chlorines are going to add to the more substituted carbon that was part of the alkyne. So I'll get both my chlorines there. Okay, here's another example. And this actually takes us back to a previous video. And so in this case, we're going to go from the dihalide to the alkyne. And so we're going to get our triple bond here. All right, now we're going to put some of these together. So we're going to react it with the strong base, sodium hydride and ammonia. Then we'll do the water workup to get rid of the alkanide ion. And then we're going to react this with HBr in the presence of peroxides. And so we're going to get anti-Markovnikov addition. So the first thing we'll do is, these two sets of reagents will give us the alkyne. Right, so that would be the product after these first two steps. Then when I react this with the HBr in the presence of peroxides, I'm going to get anti-Markovnikov addition. And so my final product would be this.